Let's expand a little bit on our orders of operation. Okay, we're going to add some properties to why we're able to do some of the orders of operations that we do. Let's expand a little bit on our orders of operations. So instead of just strictly going through the math, we're going to add the properties that go along with it. The definition in math, why we're able to do what we're supposed to do. For example, let's just get out of this. To get started off, before we start talking about some of our properties, I want to talk about what an equivalent expression means. Basically, it's just two expressions that represent the same value that are just written differently. For example, I was thinking of the distributive property in a way. So if I said 6 times x plus 3, that's equivalent to the expression of 6x plus 18 after you distribute, right? Those are equivalent. They're equal to each other. Okay? That's all it's saying, equivalent expression. Properties. Okay, so we have some properties here. And they're true for any number. For example, substitution. Basically, it's just when you replace an expression with a smaller expression. You pretty much solve part of it. So let's say I'm looking at this example right here. And I got 12 times 8 minus 2. So by changing 8 minus 2 to 6, I basically just substituted. That's substitution right there. Okay, I just substituted. It's just replacing one expression with another. Reflexive, okay, reflexive over here, that's just saying it's equal to itself. So A is equal to A, right? 4 is equal to 4. 8 plus 3 is equal to 8 plus 3. Just the same thing. Okay, it's just the same thing. Symmetric, it's kind of like reflexive, but you're basically saying I can just flip-flop the equal sign, the stuff on the equal sign. So if I say 3 plus 2 equals 5, I can flip that around and say 5 equals 3 plus 2. So it doesn't matter what's on the left and right side of the equal sign because you can flip them around, right? Transitive. The transitive property is a little bit different. It looks something like this. If A equals B and B equals C, then A has to equal C. So basically, if two things equal the same thing, then those two things are equal as well, right? Both A and C equal B, which makes them equal to each other. That would be a transitive property. Okay, let's look at some more properties here. Let's get into our identities and some of our inverse properties. First of all, when you think of identity, you think of your ID, your identification. What makes you you? Like it's just you. So I think additive identity. Well, what can I add to myself to not change it? Or what can I add to a number to not change it? Well, when I add 0. So additive identity is when I add 0. It doesn't change it, right? If I take 4 and I add 0, it's still 4. That would be the additive identity. Which I'm going to jump down. I'm going to jump down to the You could say this a couple different ways. You could say multiplicative identity, or some people say multiplicative identity. Either way is fine. I don't care. But if I look at that, same thing, identity. What can I multiply by a number to not change its identity? Well, 1, right? If I have 7, 7 times 1 leaves his identity at 7. That's what I'm thinking. So identity, think you want to keep your identity. You're not changing it, right? For inverse, additive inverse, well, inverse, I kind of think opposites, right? So additive, which means I'm adding. So if I have 6, that would mean I add its opposite. It's inverse. Well, when I add inverses, I get 0, don't I? 6 and a negative 6, they give me 0. So anytime I have additive inverses, they always add up to 0. Or if I add opposites, I always add up to 0. And lastly on the bottom, multiplicative property of 0. Well, if you multiply anything by 0, you get what? 0, right? Doesn't matter. If I took 12 times 0, I get 0. Even if I have a negative number, negative 4 times 0 is 0. Okay, so the property of 0, multiplicative or multiplicative property of 0. And my last property, the inverse of multiplying, multiplicative inverse. Well, if we look back here, additive inverse, right? 6 and negative 6. So this doesn't mean multiplying opposites. It's something a little bit different, okay? A multiplicative inverse is the same thing as a reciprocal, in a way, right? So let's think about this. Let's say I have the number 3/4. Okay, well, what is its reciprocal? Remember talking about reciprocals a few grades ago? Well, the reciprocal is when you flip a fraction, right? So the reciprocal, I'll bring it down here, would be 4/3. What happens when I multiply by its reciprocal? I end up with 1, don't I? Because if I multiply across, I get 3 times 4 is 12, and then 4 times 3 is 12, which is 1. Okay, so multiplicative inverse. A multiplicative inverse means a number times its reciprocal gives you 1, right? And just think reciprocal. Think reciprocal for multiplicative inverse. Okay? So now let's use these to justify our order of operations, or what we're doing. So it says evaluate this expression, name the property used in each step. So I'm going to rewrite my expression here, 12 minus 8 plus 3, 15, divided by 5 minus 2. Okay, so I haven't done anything yet. Well, first thing first, I go inside parentheses, don't I? Well, if I use the same property for multiple steps here, I can combine them all in one step. So like if I look at what's inside these parentheses, all I'm going to do is substitute. Okay, there's nothing else that occurs in here. Because if I think 12 minus 8, well, 12 minus 8 is 4. I just replaced 12 minus 8 with 4. So that's substitution. Also in here, 15 divided by 5 is 3. And 3 minus 2 is 1. Okay, so all I did was I substituted. Substitution. So I just combined 2 steps into one because it was the same property, substitution. Now I look at it, well, I have multiplying and I have adding. So I got to multiply first according to my PEMDAS, and I got to work left to right. So 1/4 times 4. Well, what is that? That's really 4 over 1, isn't it? And 1/4 times 4 over 1 is 1, right? Because they're reciprocals. Multiply by its reciprocal. Well, I'm not going to do the 3 times 1 yet, because what property did I just use? I just used the multiplicative inverse property. All right, that's just what we talked about. Well, now I can do my 3 times 1. Well, 3 times 1, and when you take a number times 1, it doesn't change, right? It stays as 3. So that's really what? The multiplicative identity, right? When you do multiply to not change it. Identity. And if you want to shorten this and say like MULT period or something, that's fine. Multiplicative identity, I'll be able to tell. And lastly, 1 plus 3, I'm just replacing that with 4, right? So I substituted. And, you know, S-U-B-S-T, I know that you're saying substitution, okay? So you're just naming the property that you do in each step. I know you think it's kind of pointless, but it's good to just get used to some of these math terms and why we can do what we can do. So it doesn't take that much extra time, but let's use our properties here. A couple more properties, stuff that you've learned before. Commutative property, it just means the order in which 2 numbers are added does not change their sum. So if I take 4 plus 3, that's the same thing as if I take 3 plus 4, right? Same thing with multiplication. I can change the way I multiply. So 4 times 3 is going to be the same answer as 3 times 4, right? I can flip the order. Associative, now we're just bringing 3 or more numbers into play. So for example, if I have 2 plus 4 plus 7, and I add 2 and 4 first, I'm going to get the same answer as if I added 4 plus 7 first, right? It does not matter which order I do when I add. And the same thing goes for multiplying, right? If I took 2 times 4 times 7, if I multiply 2 and 4 first, it's not going to change than if I did 4 times 7 first, right? You can do it any order you want with multiplication or addition. So for example here, Rafael's buying furnishings for his apartment. He buys a couch for $300, lamps for $30.50, a rug for $25.50, and a table for $50. Find the total cost of the item. Well, this is saying if you didn't have a calculator, according to your commutative and associative properties of addition, I can change the order I want to add. So I might want to add these two together right away because there's no cents. So those total $3.50. And I could add the ones with the 50 cents because what? 50 cents and 50 cents gives me $1. So these total $56. Well, now I can just add these two, and I don't need a calculator, for $406. Okay, so using those properties help you with your mental math. Okay, and the same thing works with multiplication. I'm not going to say, you don't have to name the property here, okay, but just show me which ones would I multiply together first to save me some time. So I wouldn't need to use a calculator. I wouldn't need to use my long multiplication. Well, if I think about it, if I can multiply to a 10 or a 100 or any power of 10, that always helps, isn't it? So if I took 2 times 5, because isn't that 10? Well, that's going to help me. Because what's 8 times 7? 56. Well, if I multiply anything by 10, all I have to do is what? Add the 0. So 560. Okay, so it's just using your properties to get your mental math so you can work a little quicker. Okay, so it's kind of the same thing as the other day, order of operations, except we're applying a property to why we're able to do something.